So based on the three categories, okay, we divide it in we categorize it as three zones. Okay, zone 1, zone 2, and zone 3. So zone 1 is tightly bound, zone 2 loosely bound, zone 3 trap or free water. Okay, so in zone 1 or type 1, where the water is tightly bound to the food components such as sugar, salt, glycerol, it needs very intense drying condition to remove the water. Okay, and in terms of free water, there's no free water, so that's why it's unavailable for microorganism growth. Whereas in zone 2 or type 2, the water is loosely bound. Okay, so some of the water bound to food component, some are not, and the one that are not bound to the food component is the one that is available for the microorganism growth or other chemical reaction that leads to food deterioration. And in zone 3 or type 3, this is where there are sufficient or there are ample of free water. They are available for chemical reaction to occur, which support the microorganism growth that leads to food deterioration. In this type of water, because they are free water, they are freezable. You can freeze the water. Okay, like tightly bound, like zone 1, it's unfreezable. Okay, so if you try to put food without free water inside the freezer, it won't freeze. Okay, because there's no free water that can freeze. Okay, so this is just to sum up the three zone. Okay, zone 1, zone 2, zone 3. Okay, highly perishable, intermediate, and chef stable. So these are the different type of food and their water activity values. Okay, for example, meat. Okay, fresh meat, it is having high water activity value, means highly perishable. So that's why meat, if you don't put it in fridge or freezer, it will easily becomes rotten. Okay, due to the high water activity, which enable many types of chemical reaction. Honey, dried fruits, those are categorized as the intermediate moist food, which is high, more stable compared to the highly perishable food, but the shelf stability is still short. Okay, it's not as long as the chef stable food like dried pasta. Okay, the water activity value is 0.5. Notice that honey, although it looks like very moist, it is categorized as intermediate moist food because most of the free water are bound water. Okay, bound water. Okay, this table shows different type of microorganism and the water activity value where it is very active. Okay, for example, normal bacteria will likely to grow in food having high water activity. Same goes to the normal yeast. Okay, normal mole slightly lower water activity value 0.8. So if you have food with water activity less than 0.8, more this normal type of mole will not likely to grow. Halophilic bacteria is salt loving bacteria, means it is very likely to grow in salt environment. Okay, so even though your food having water activity that is low, but if it is having salt properties, okay, salty, then halophilic bacteria likely to grow. Xerophilic mold and osmophilic yeast, this type of microorganism are the one that easily can adapt to environment of low water activity. Means even though the food is categorized as intermediate moist food, but if it exposed to this type of microorganism, the food can still get spoiled. So next is psychrophytes. Okay, this type of microorganism grow only at refrigeration temperature. So sometimes you will notice, even though you put your food inside the fridge for the purpose of extending the shelf life, somehow mold or yeast can still grow. Okay, and this kind is most probably belongs to the psychrophytes group. Okay, so psychrotrophs will grow well at refrigeration temperature, but even better at room temperature. So if you put food in fridge, okay, eventually it gets spoiled. Okay, you only slow down the process. Okay, spoilage process, you slow it down. Mesophil will grow best at or near human body temperature, but grow well also at room temperature. Okay, thermophils organism grow at temperature as hot as the human hand can endure, but not at below body temperature. So these are the different type of microorganism, to be more specific in terms of their names and the range of activity that they work best. Okay, and the type of food with that range of water activity. Okay, so you just go through the table and see the name of the bacteria, okay, the range of the water activity, and also the type of food. Okay, so notice that at water activity 0.5 and below, no microbial growth. Okay, no microbial growth. So it's quite active in the intermediate moist food and highly perishable. fruit. So, how does water activity help the food manufacturer? Okay, so based on water activity, okay, food manufacturer can select the right ingredient for a food product. Okay, for example, it will be possible to create multi-textured food. Okay, if the component that are used are at the same water activity. Okay, for example, you go to the supermarket and buy Kit Kat ice cream. Okay, the cone one. So in the center of the ice cream, you'll find a bar of Kit Kat chocolate, and it's still crispy, although it is surrounded by the soft ice cream. Okay, and how is this possible? Okay, due to the same water activity of the ice cream itself and the Kit Kat chocolate in the center. Okay, so if the water activity are the same, there is no moisture migration. Okay, moisture migration will occur if there is different in terms of water activity. Okay, so if you live with your grandparents, for example, um, they will have this belief that don't mix different food in one container, right? Because they say the food will get soggy, okay, or the cookies will get soggy because you mix it with different type of cookies. Okay, that is actually logic because the different biscuits may have different water activity, one with high water activity, one with low water activity. So it means moisture migration will occur from high to low, and that's why the food will get soggy again, and it is no longer crispy. Now, if you look at this graph here, okay, uh, again, moisture content versus water activity. Okay, so soft moist pieces is this curve here, whereas hard dry piece is this curve here. Okay, of course, based on the sorption isotherm of moisture content versus water activity, high moisture content, of course, high water activity. Okay, so low moisture content, low water activity. Okay, so if you have low moisture content at high water activity, you get hard dry piece. Okay, due to the water activity, because the food texture is still controlled by the water activity. Okay. Here you have high moisture content, high water activity, so you get soft moist piece here. Okay, okay, note that these are at the same water activity, but different moisture content. Okay, so we will look at example of texture changes when food at different water activity are mixed together. Okay, for example, you're making sandwich. Okay, and normally in your sandwich you put lettuce, you put mayonnaise, you put tuna, you put all these ingredient which are in the high water activity value. Okay, and the bread itself is in the mid range or in the lower water activity value. So when these two are mixed together, moisture migration will occur, and no moisture migration will occur from food at high water activity to food at low water activity, and that is why when you prepare the sandwich in the morning, later in the afternoon, it won't taste as good as in the morning. Okay, because it already turned soggy. The bread already turned soggy due to the moisture migration from the ingredient to the bread itself. Okay. Another example is when uh, when you want to um, mix let's say mix cornflake in the morning with milk. Okay, once you mix, normally you eat it straight away, because if you leave it, the cornflake will become very soggy and won't taste good. Okay, so this is one example why food manufacturer need to know the value of water activity of food, so that they don't prepare food that end up change in terms of the texture. Okay, so if you look at this example here, okay, caramel, marshmallow and mince, these are all similar in terms of their moisture content, but very different in terms of the water activity. So that is why water activity value is important compared to moisture content. You can have food, uh, two different food that 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 are moist, but in terms of the water activity, they're different. Okay. So if you have fudge, okay, with water activity in this range of 0.65 to 0.75, covered with caramel, which has the water activity in the range of zero point 0.4 to zero point 0.5, what would happen? Okay, so you would expect moisture migration occurring here. Okay. Another example is granola bar, okay, with soft, chewy matrix with water activity of 0.6, and then you coat it with sugar at lower water activity of zero point 0.3. So what will happen? Okay, so you know, because there are two different water activity here, moisture migration would occur. Next we will look at different of chemical reaction in relation with water activity. Okay, the first one is microbial stability. Okay, most food at high water activity, okay, or the perishable group of food, would require refrigeration because it will slow down bacterial activity. Okay, so when you put food in the fridge, it will prolong the shelf life because it slows down the microbial activity. Okay, exception is acidic food. Okay, acidic food you don't need to refrigerate because it's resistant to bacterial activity, and that is what in one of the oldest technique to preserve food is pickling. Okay, by using vinegar. Okay, because they are acidic. Okay. For intermediate moisture food having water activity in the range of 0.6 to zero point 0.9, again, refrigeration can help. Okay. Food with low water activity, less than 0.6, will prevent microbial spoilage even at room temperature. So that's why you don't put biscuit in the fridge. Okay, you put it in container, good enough. Okay, so that it won't become soggy due to moisture migration from the surrounding. Okay. Food at water activity in the range of 0.7 to zero point 0.9, which normally will have moisture content of 20 to 50%, can be dried or we can bound this free water. Okay, for example, food that undergo these processes includes dried fruits, jelly and jam, pet foods, fruity cakes, sausages, marshmallow, and bread. Okay, so if you notice, jam in the market, it looks very moist. Okay, but the shelf life is long because the moisture content are bound to sugar. Okay. For the intermediate moisture food, okay, um, it will need only minimal processing in order to prolong the shelf life. Okay. Um, the problem that can address the microbial stability of food in this range of zero point 0.6 to zero point 0.9 water activity is by adding mold inhibitor, or in order to avoid lipid oxidation process, we put antioxidant or put the food in inert packaging. Okay. And then this kind of microbial stability is also important in grain because we want to prevent mold growth, okay, and then possibly mycotoxin development. Okay, so that's why grain normally the water activity must be below 0.8. Okay, otherwise mold can easily grow. So the next chemical reaction that leads to um, food stability, okay, is chemical stability. Okay, one of the example of chemical reaction is mallet browning. Okay, so what is mallet browning? Okay, mallet browning is a chemical reaction between an amino acid and a reducing sugar. Okay, so what is reducing sugar? So reducing sugar, okay, is a type of sugar which have either ketone or aldehyde group. Okay, so if you have food, okay, containing amino acid and also reducing sugar, then most likely the food will undergo mallet reaction. Okay, we will look at reducing sugar in more detail under carbohydrate. So this type of mallet reaction, okay, will lead to color change, flavor change, and odor change. And these changes can be desirable or it can be undesirable. Okay, and mallet reaction normally would reduce the availability of essential amino acid, for example lysine. So we look at essential amino acid in detail in learning unit protein. Okay, so our body need essential amino acid, that's why it's classified essential. Your body needs it from food. Okay, and mallet reaction can leads to decrease in this essential amino acid content. Okay, another reaction, another effect of mallet reaction is reducing absorption of zinc. Okay, so we need zinc also in our diet. Okay, however, this absorption of zinc would not occur below type 2 water, means type 1. Okay, the low water activity range. However, it increase in type 2, okay, because more water is available. Okay, more free water, ambang water. So the next chemical reaction that have very strong relationship with water activity is the lipid oxidation. Now this could enhance, or this could initiate in the presence of water and also oxygen. That's why oxidation. Okay, if the food is very high in water activity or very low in water activity, lipid oxidation rate are high. So you can refer this to a video that I have shared in ELIP. Okay, and this is due to the instability of the hydroperoxide. So this hydroperoxide is not stable and easily decomposed into secondary compound, and secondary compound are example are aldehyde and ketone, and these are the compound that responsible to rancidity. Okay, rancidity means undesirable taste to the food. Okay, so if your food contain lipid and that food is exposed to air, okay, oxygen, and also water, then it will initiate this lipid oxidation. Okay, so this hydroperoxide, okay, can be avoided, okay, if the food is put in inert packaging, so that it won't allow interaction of the food with oxygen. Okay, so above type 2, you will learn this in more detail, okay, under learning unit lipid. Okay, the mechanism of hydroperoxide. So above type 2 water means more free water available. It will promote lipid oxidation. Okay, because it dissolves the catalyst for the reaction. Okay, so these are the effect of lipid oxidation. It leads to loss, flavor quality, rancidity, change in terms of color and texture, even nutritional quality loss, and also loss of essential fatty acid and vitamin. So the next one is vitamin and pigment stability. Okay, ascorbic acid or vitamin C, they are very unstable at high water activity because easily oxidized. Okay, so the stability of vitamin and also pigment is best in low water activity food. Okay, type 2 and below. So the next chemical reaction that very close related to water activity is enzyme stability. Okay, so this enzyme activity would need water, okay, in order for it to initiate or react. Okay, because the presence of water will help to solubilize the substrate and then mobilize the reactant, okay, for further reaction of enzyme. So in dried foods, okay, means water activity is very low. Okay, the enzymatic reaction, of course, very less likely to occur. Okay, so that's why enzyme stability enzyme activity is not significant in dehydrated foods, okay, which is type 2 in below. There are some exceptions in which even at low water activity, enzyme activity can occur, and this exception is referring to lipase. Lipase is enzyme in which the substrate is lipid. Okay, so if you have that's why when you put butter, so butter is example of lipid containing product, you put butter on the table and you leave it for days, and after that few days you would detect a very undesirable smell. Okay, that is due to the enzyme activity. Okay, the lipase, it works on the lipid in the butter, okay, and produce undesirable smell, okay, due to the lipid activity, enzyme activity. So this table sum everything, okay, between water activity value and also pH. So which one is shelf stable, okay, or have long shelf life. Okay, so acidic food, okay, in which the pH is less than 4.2, mostly the food are all shelf stable even at low water activity to high water activity. Okay, so that's why you see an exception in terms of acidic food. Just now we don't need to refrigerate, and when you increase the pH from 4.2 to 4.6, the food that has high water activity is no longer shelf stable. Okay, further increase in pH, okay, which is more than 4.6, okay, to 5, again the shelf stability is only up to 0.9 value of water activity. More than that, it's no longer shelf stable. Again, in further increase in pH, which is more than pH 5, okay, less acidic now, so food is only shelf stable at low water activity. Okay, so next we move on to different reaction, okay, at range of water activity from 0 to 1. So I have mentioned lipid oxidation as just now. So you see, this is the typical curve for lipid oxidation. That's why food in high water activity and low water activity, yeah, is very prone to lipid oxidation. Okay, and it is minimum at this value here, around 0.2. So that's why food manufacturer, if they produce lipid containing product, okay, the water activity is desired at this value because the lipid oxidation is minimum. Okay, exception of lipid, other chemical reaction would not occur at zone 1, okay, low water activity. So food at this range here will not undergo enzymatic browning, will not undergo non-enzymatic browning, enzymatic activity, microbial growth, so it's very stable here. Okay, and then you look at high water activity, all chemical reaction is high. So high water activity food will most likely to undergo non-enzymatic browning, enzyme activity, as well as microbial growth, and also lipid oxidation. Okay, so that is why it is important for food manufacturer to determine what the activity of food, because it is directly related to shelf stability of the food. Okay. Humectant. So what is humectant? Okay, by definition, it is a substance used primarily in food and also cosmetic products in order to reduce water activity, because this humectant will bound to the free water. Okay, and this kind of substance, they are called hygroscopic. Hygroscopic means they are able to absorb water. Okay, means high water binding capacity. For example of humectant include sucrose, propylene glycol, glycerol, sodium chloride, okay, salt. So these are good water binding substance, okay, to decrease water activity in food, and thus extending the shelf life, okay, or improve the shelf stability of food. Now look at this curve here. Okay, so this curve is representing crackers, cream crackers, during transportation. Now temperature is also an important factor for food manufacturer, because it will also affect the shelf stability of food. Okay, during the production, okay, the the temperature is around 25 degree. Okay, but then during transportation, okay, which is not controlled, okay, okay, if it's not controlled in term of the temperature, okay, in the lorry, for example, then the lorry park under very sunny day, okay, for break, okay, things like that. So note that the water activity would change drastically at the same moisture content. Okay, let's say the moisture content of that cream crackers is let's say we look at this region here. Let's say if the moisture content is 0.05, the water activity at processing environment is only 0.3, but during transportation at 35 degrees Celsius, you have a change in terms of its isotherm, and the water activity now increase to 0.7. So which one will spoil faster? Okay, to sum up, in order for us to control water activity in food to prolong the shelf life, we remove the free water. Okay, either using techniques like dehydration, drying, freezing, okay, or we can add humectant. Example of humectant includes sugar, sodium chloride, glycerol, propylene glycol. And that ends our first learning unit.